structure and office hours and all of that, and then we will jump into the actual contents.
Yeah, so quick overview. This is also available on the GitHub in the main folder for the data science. We're gonna do each week. We want to do these tutorials where we do it live and it's recorded, but we want to have it on live so we can just do like open Q&A and just have more discussion based sessions. And then if you aren't able to make the live ones each week, they are recorded. We will share them with you guys. And we have labs that are to be completed on your own time outside of these. And then our office hours will be with Kyle. We have a poll in the Slack channel right now to see which times work best for everyone because everyone has different class schedules. So we want to work with everyone to make sure they do have a chance to ask any questions they have. If you don't want to like set up an office hours meeting or whatever, you can just send your questions in the Slack and someone will answer those. So if you're not in the Slack, just send me a message and I can set that up.
Okay. Awesome. So with that, we will jump into the actual content. So this week is an introduction to Python. So for those of you computer science majors, this will be more of like a review. And for those of you who have never touched computer science before, this will be a little bit new. So this will always be available for you all to look at. So I will try and get through as much content as possible. If I'm going way too fast, please say something in the chat, but just keep in mind that this will be available for everyone at all times. So
just in case anyone isn't like familiar with GitHub or any of that, could you show how you get to this page really quick?
Oh, yeah, of course. Okay, so let me get the link. Okay, so this is all hosted on GitHub. Let's see, so this is a direct link to week 1, but if you just click on the Bitcamp data side, you will have access to both, or I mean, week 1, week 2, and week 3. So we'll click on week 1. And then right now we are actually doing the intro to Python plus NumPy. So we'll click on that. It'll bring us to this, but you're not really able to run things while just looking at this. So if you click this little open in Colab, it'll bring you to a Jupyter notebook in which you're actually able to run all of the code just by pressing a button. Yeah, so for example, we can do like that. Oh, run anyways. And you're able to just run it. So this is also how you will be doing, I believe, your labs as well. But I do have to double check on that. And also to get to your labs, let me do that really quickly. So we'll go back and leave. In the same folder, there should be a folder called lab. So just click on that and it'll bring you to, a Jupyter notebook, which you'll open in Colab. And there are, I think, like 6 questions, 8 questions that you'll have to do. Again, if you have any questions about the lab, which you'll have to do after this class, please contact either Danae, I, or Kyle, which again is the Google engineer. Awesome. So with that, I will get started.
And then don't forget for this notebook to copy to your drive.
Oh, so okay. Yeah, that right there. Awesome. Okay. Why, where, and how we use Python. So Python is a very popular scripting language that you can use to create like applications and programs of all sizes and complexity. It's very easy to learn and has very little syntax, which makes it very efficient to code with. Python is a language of choice for many when performing comprehensive data analysis. So again, this is mainly why we'll be using this for our data science Bitcamp. So today, we will focus on understanding key Python data types, operators, and data structures, understanding functions, modules, and we'll be going over some errors and exceptions that you can run across. Okay, so the first data type we'll cover in detail is numbers. So again, as I said, if you are a computer science major, this will be a big review. But for those who have not touched computer science before, this will be new. So numbers, types of numbers. So Python has various types of numbers. Today we'll cover integers and floating point numbers. So integers are just whole numbers, positive or negative. So for example, 2, 4, or negative 21 as an integer. Again, they just have to be whole numbers. Floating point numbers in Python have a decimal in them or use an exponent or an e. So for example, the number 3.14 and 2.17 are floats. And also 5e, 7, which is 5 times 10 to the power 7 is also a float. So this is called scientific notation, and you've probably seen this in either math or like chemistry or something like that. But for now, let's start working through the basic arithmetic. All right, so in Python, to add something together, all you have to do is put a plus sign in between the two numbers that you'd like to add. Okay, let me do that again. Maybe it should be, yeah, okay, so we already have that, but it's 9. So for subtraction, again, it's just the normal subtraction sign. So here we do 5 minus 10, and we get negative 5. I've already run this before, so this is, it's already filled out. But so for multiplication, 4 times 8, the multiplication symbol, unlike normal, is just the asterisk. So yeah, that's how you do multiplication. I guess we'll run it anyways. Here we have division. Normal division is just 25, or you just use the forward slash. So for example, here we have 25 divided by 5. This will give us 5.0. So next we have floor division, which is a special type of division. This is signified by 2 forward slashes. And when we do 12 divided by 4, we get 3. So what actually happened here? So the reason we get this result is because when we're using the floor, for the second one, we're using the floor division. The 2 forward slash operator removes any decimals and doesn't round. So this will always produce an integer versus the one before this, which is the 25 divided by 5, which gives us a floating point number. Alrighty, so what if we just want the remainder of division? For this, we have the modulo operator. In this case, it's a percentage sign. So we can do 9 mod 4, and we get 1. Again, because 4 times 2 is 8, and the remainder would be 1. Right. Alrighty, so we will continue with the arithmetic. Here we have powers. So in order to do like 4 to the power of 2, we would have the double asterisk. That would give us 16. So we can also do roots this way, but instead of having a whole number, we would have a floating point number. So for example, here we have 144 to the 0.5 power, which will be like the square root of 2. So we get, square root of 144. So we get 12. Here we have the order of operations. So again, Python follows the order of operations. So first we would do, PEMDAS and all of that. So we would do multiplication first and then add from left to right. And that is how we get 1049. Awesome. And then we can also use parentheses to specify orders. Here we would do 21 plus 5 first, and then we would do 4 plus 89, and then we would multiply these two together to get 2,418. Awesome. So next we will go into variable assignments. So there's a lot more we can do with Python than just using it as a calculator. We can store any number we create in these things called variables. So we use a single equal sign to assign labels or values to variables. And here we have a few examples below. So here we have a variable called a, and we will assign it to the number 10. So we just say a is equal to 10. And so when we print this out, we should get 10. Wait, Danae, is there a way I can like undo all of the things that I've done? Because I feel like it's a little spoilers having it already printed out.
Like to reset the notebook. Let me look at that. 1 second.
Hold on. Let's try this maybe. Yeah, I just I feel like having the answers already printed out is a little bit okay. Now we love that.
I'll look. You can just keep going and I'll look for you.
Okay, awesome. That works. Okay. Alrighty, so back to variable assignments. So now if I call a in my Python script, Python will treat it as an integer 10. So if we add the two variables or the same variable twice, so we could do a plus a, we will get 20. So Python also lets us reassign variables. So here is the a from above, which was previously 10. We could set it equal to 20. And then when we print out again, we will get 20 instead of the previous 10. So Python allows you to write over assigned variable names. We can also use the variables themselves when doing the reassignment. Here is an example. So here, we will actually use a to redefine a. So we will set a equal to the sum of a plus a. And previously, a was 20. So now when we print it out, it should be 40 because 20 plus 20 is equal to 40. Alrighty, so when you're actually writing code, there are a few rules when naming your variables. So names cannot start with a number. Yeah, that's just something that Python says that we can't do. So names cannot start with a number. There can be no spaces in the name. So instead, underscore is used instead. Also very commonly, you might see camel case when like the start of each word besides the first word is actually capitalized. So you can't use any of the following symbols in your variable name. Again, that's just something that Python says that we can't do, so we won't do it. Using lowercase names are the best practice. Again, they don't have to be lowercase, but it's just, you know, normal for us too. And then so there are certain words in Python that we just can't use for variable names, like list and str, which is string. And that's because like they're special. So we have to, those are reserved for special cases and we can't use them. Alrighty. So using variable names can be very useful when keeping track of different variables in Python. So for example, here we use object names to keep better track of what's going on in your code. So here we're calculating our taxes. So we will set income equal to 1,000, our tax rate equal to 0.2, and then we will calculate our taxes by doing taxes is equal to income times tax rate. And then here we show the result. So again, it was very easy just to read through that and see like what exactly we were doing instead of maybe using like A and B and C. So again, just best practice, try and have very descriptive variable names. Alrighty, so what have we learned? We've learned some of the basics of numbers in Python. We've also learned how to do arithmetic and use Python as a basic calculator. We then wrapped it up with learning about variable assignment in Python. And now we will learn about strings. Awesome, so let me do that. So strings are used in Python to record text information, such as names. Strings in Python are not treated like their own objects, but rather like a sequence, a consecutive series of characters. So for example, Python understands the string hello to be a sequence of letters in a specific order. This means we will be able to use indexing to grab particular letters, like the first letter or the last letter. So Here is how we will create strings. So to create a string in Python, you need to either use single quotes or double quotes. So for example, here, this is a string. Again, it's just 2 characters encased in some single quotes. A string can also be a long phrase like this, or a sentence. And then we can also use double quotes to create a string. Again, it doesn't really matter. But we do need to be aware of like contractions and apostrophes in our sentences if we're using those. So for example, here, when we run this, we actually get an error. And it points us to this second apostrophe here. So in order to fix this, we have to encase the whole thing in double quotes. And when you do that, these little apostrophes shouldn't cause an error. So for example, when we run this, yes, this shouldn't cause an error, even though we do have an apostrophe in here. Alrighty, so let's learn about printing strings. So Jupyter Notebooks have many neat behaviors that aren't available in base Python. One of those is the ability to print strings just by typing into a cell. So the universal way to display strings, however, is to use a print function. So for example, in a Jupyter Notebook, this is all we need. All we need to do is just have the string or variable there, and then when we press run, it'll print it out for us. But when we're actually coding, we need to have a print statement, which will just be print parentheses and then whatever we want to print out onto the console. So yes.
Real quick, if you click edit at the top, there should be a clear all outputs at the bottom. Yeah.
Amazing. Thank you so much. Okay. All right. So without the print function, we can't print multiple times in one block of code. So for example, if we wanted to print out hello world and second string, we could not. Only the second string will print out. However, using print statements, we can print out as many things as we'd like. So here we have a print statement for hello world, second string, a new line, another new line, and then another print statement just to prove it to you. So when we run this, all of our print statements will come out. Yeah. So now let's move on to understanding how we can manipulate strings in our program. Okay, so oftentimes we'd like to know how many characters in a string. We can do this very easily with the ling function, which is short for length. So when we call that function on hello world, we should get 11 because there are 11 characters in this string. So Python's built-in length function counts all of the characters in the string, including spaces and punctuation. So naturally, we can assign strings to variables like we did earlier with the numbers. So here we're assigning hello world to my string. When we, and then to check to see if it works, so we'll just print out my string. And when we print out my string, we get hello world. And then we will do it again, just using the print statement just to show you all that it works. And we get the same thing, hello world. Okay, so as stated before, Python treats strings as a sequence of characters. That means we can interact with each letter in a string and manipulate it. The way we access these letters is called indexing. Each letter has an index which corresponds to their position in the string. In Python, indices start at 0. So for instance, in the string hello world, H has an index of 0, E has an index of 1, and W has an index of 6. And this is because the spaces count as characters. And then finally, D has an index of 10. So here we have a few examples. So here we will extract the first character in a string. So when we call 0 on my string, we get H. And again, that's because when these indices start at 0. So when we call my string on 1, we get E. And then when we call this one, we get L. Awesome. So we can also use the colon operator to perform slicing, which grabs everything up until the designated index. So for example, when we call like the colon on my string, it will grab all letters past the first letter all the way up until the end of the string. So just to show you all what that looks like, hello world. So when we call it, the whole thing will just print out. And just to show you all that it does not change the original string in any way, we will print out my string again. Okay, and again, it prints out hello world. So then we want to grab everything up to the 5th index. So in order to do that, we will have the colon and then 5. So to show you all what that looks like, we have hello. And again, it does not include anything 0, 1, 2, 3, 4. Yeah, it does include the 5th one, but it will include everything up until the 5th index. Oh, there we go. Yeah, so note what happened above. We told Python to grab everything from 0 up to 5. This does not include the 5th index. So you'll notice this a lot in Python where statements are usually like in the context of up to, but not including this number. Alrighty, so again, just to review, this will be, this should give us the whole string because we don't have any arguments. All right, so the default values, if you leave the sides of the colon blank, are 0, and the length of the string, oh, actually, I don't know what that is. Hold on, let me see. So see that it matches above. So we have the length of my string, and that we set that equal to end, and then we want to see that it will print out the whole string for us. So again, we call it from 0 up until the end, and we get hello world. All right, so we don't necessarily have to go forward. So negative indexing allows us to start from the end of the string and work backwards. So for example, here we call my string and then brackets -1. So this should give us the very, very last letter. Yes. Yeah.
I had a quick question on the last one. We're talking about the string and they used the len. So wouldn't that my string 0 to end, which that end is the length of the string, wouldn't that just end with the last one before it, not the whole thing, but stopping at like that L, or no?
Right. So the thing with length is, well, it'll actually get all of the characters we have. So for example, in hello world, we have 3, 4, 5, including space, 6, 7, 8, 9, 10, 11. So it really looks like 0 to 11. But again, it doesn't, because our indices start at 0. Okay. All we really need is like 0 to 10. And the way that, yeah, does that kind of make sense?
That makes sense. Yeah, appreciate it.
Yeah, of course. And yeah, again, just a reminder, everyone, if anyone has questions, please let me know. Okay, so here we can grab everything but the last letter. So here we will call colon and then -1, and we get hello world. So yeah, just the way that this works, it's amazing. All right, so we can use indexing and slicing to grab characters by specified step size. 1 is the default. So here are some examples. So here we'll grab everything, go in step size of 1. So again, this is the default. So we get hello world. But here we can grab everything but go in the step size of 2. So this will grab every other letter for us. So here we get hello word. So again, it's just not including every other letter. And then this is really, really useful. So this is a handy way to reverse a string. So in order to do that, we just call it the double colon and then -1. So here we get hello world, but in reverse. All right, so strings have certain properties to them that affect the way we can and cannot interact with them. So here are some of the string properties. So it's important to note that strings are immutable. This means that once a string is created, the elements within it cannot be changed or replaced. So for example, so let's just print out my string to see what we have in it right now. So we have hello world. Let's try to change the first letter of hello world. So we'll, right now we're trying to set A equal to the first letter. Here we get an error. Yeah, so it just says string object does not support item assignment. Yeah, so the error tells it to us straight. So strings do not support assignment the way other data types do. However, we can concatenate strings. So again, let me print out my string just to show you what we have. Here, we can combine strings through concatenation. Oh no, wait. This meeting has been upgraded by the host. Oh, cool. Okay, awesome. Right, so here we can combine strings through concatenation. So in order to concatenate strings, we just have to take two strings and put a plus sign in front of them. So here we should get hello world, it's me. And again, that's just what we had in my string, which was hello world, plus a string that includes a period, it's me. All right, so we can reassign my string to a new value, however. So for example, here, we will set my string equal to my string plus it's me. So when we print that out, we should get hello world, it's me. But this time it's just in my string now. So one neat trick we can do with strings is use multiplication whenever we want to repeat characters a certain number of times. So for example, let's set the variable letter to a character A. When we do this and call multiply it by 20, we should get 20 A's. Yeah, so that's pretty cool for repeating strings or characters. All right, so we already saw how to use length, but this is an example of a built-in string method, but there are quite a few more which we'll cover next. So here are some more basic built-in string methods. So objects in Python usually have built-in methods. These methods are functions inside the object that can perform actions or commands on the object itself. So we call methods with a period and then the method name, and they're in the form object.method and then whatever parameters we will have inside. Parameters are extra arguments we can pass into the function. And again, don't worry if these details don't make 100% sense right now. We'll go into some depth about these later. So here are some examples of some built-in methods for strings. So first I will print out what we have in my string. So here we have hello world, it's me. So when we call dot upper on my string, it will make all of the letters in this, the string uppercase. So when we do this, we get hello world, it's me, but in uppercase. Then we can also do the same thing with dot lower. This will just make everything lowercase. So again, we get the same statement, but it's all in lowercase. So we can also split strings with a specified character as a separator. So spaces are the default. So let me just show you all what that means. So now we have like a list of the strings. And again, it split it wherever the spaces were. So that way we have hello world, it's me, but all separated. And then we can also split by specific character. So this doesn't include the character in the resulting string. So if we call dot split of W on my string, we will get hello world, it's me. But it split it at W. So we have hello separated from the rest because it starts at W. That makes sense, hopefully. All right, so here, there are a few exercises that you all can try. Danae, should we do this now or should I keep going through the content?
I think you can keep going. How much do we have left for this section? I don't remember. Because I know that, like, I want to get to dictionaries.
Yeah, like there's some more complicated things in here. So if we can ask you all to try this after or before the lab, that would be great.
Or now.
Huh?
You can multitask. I said, or now if you want to multitask. Like if you have Zoom up on one screen and this on another screen.
Yeah, definitely. If you want to pull this up now, again, Danae dropped the link earlier, I can drop it again. If you want to multitask and try these, please do that. But for now, I think I will move on just because there's some more complicated things that I would like to get through. So yeah. All right, so again, please try these on your own. They're just, for example, like given the string, give an index command that returns D. So like how would we get the D from string S? How would we reverse it? And then extract the letter M using negative indexing. So again, these are all things that we've done above. So yes, please feel free to look back into the notes. Awesome. So now we will move on to Booleans. So Python comes with Booleans, which they're values which are pretty much binary, or true or false, or 1 or 0. It also has a placeholder object called none. So let's just walk through a few examples of Booleans. So here we're going to set A equal to true. So let's do that. And then when we print A, we should get true. Awesome. So we can also use comparison operators to create Booleans. So we'll cover this in a little bit more detail later. But here we have 1 is greater than 2, which it's not. So when we do this, we should get false. Awesome. So we can use the none, or yeah, we can use none as a placeholder for an object that we don't want to reassign yet. So sometimes you'll come across this where you kind of have to have your variable there already. In this case, we can just set it equal to none if we don't know or can't put a value in there yet. And so just to show what B looks like, it'll just print out none. So that's pretty much it to Booleans. So next we will start covering data structures. And first we'll go into is lists. Awesome. So earlier when discussing strings, we introduced the concept of a sequence. So lists is the most generalized version of sequences in Python. Unlike strings, they are immutable, meaning that elements inside a list can be changed. So lists are constructed with brackets and commas separating every element in the list. So first we'll see how we can actually build a list. So here we have we'll assign a list to a variable named myList. So here again, we have our brackets, and then inside we have each of the elements separated by a comma. So we just created a list of integers, but lists can actually hold elements of multiple data types. So for example, here we have a list which has a string, an integer, a float, and a character. And it compiles just like the rest of everything else. So just like strings, the length function will tell you how many items are in the sequence of the list. So when we call length on my list, we should get, what should that be, 4? Yeah, 4, because there are 4 items in the list. Again, here we will set, So here we set my list equal to a new list, which has 1, 2, 3, 4, 5, except some are strings and some are integers. So here, when we grab an element at index 0, again, it kind of works just like the strings. So it'll grab the very first one that you see. So in this case, it grabs 1. Again, just like strings, you can use the colon operator to grab everything up to or past a number. So for example, here, we'll grab 1 and everything past it. So when we print that out, we should get 2, 3, 4, and 5. And then here, we can grab everything up to index 3. So when we call that operator on my list now, we get 1, 2, and 3. Awesome. So we can also use the plus operator to concatenate lists, just like we did for strings. So here we'll add my list and add a new item. So we have our list from before, and then we added new item to the end. And so this does not actually change the original list. So when we add my list, when we print out my list again, we get the original list. So in order to actually change it, we have to set my list equal to my list plus whatever we want to add to the list. So when we print that out, we should get that new element that we added at the end. Alrighty, so we can also use the asterisk operator for a duplication method similar to strings. So for example, here we have my list, and then we will multiply it by 2. So here we have all of the stuff that we had before, but we have it twice. Yeah, so again, doubling is not permanent. So when we actually print out my list again, we have what we had before. So we can also use the append method to permanently add an item to the end of the list. So instead of calling like list1 is equal to list1 plus an element, all we have to do is do list.append and then whatever you want to add to the list. So for example, here, we want to append me using, oh, what just happened? List1 not defined. Oh, hold on. Oh, that's weird. Okay, my list. So just now we got an error saying list1 is not defined. Again, we didn't actually call list1 up there before. So when we just call my list dot, oh, sorry, there is a underscore. Phew, okay, so yeah, that happens a lot with coding. Sometimes, oh, here we go. My underscore list. Awesome. Yeah, sometimes variable name just gets, yeah, you kind of have to pay attention to what you've named your variables, and it's very, very easy just to misspell something and then spend a long time trying to fix it, but in reality, there was nothing wrong with it in the first place. It's just a variable name or misspelling or something like that. So we love coding. That's just part of the process. All right, so here is a little bit more advanced feature called list comprehensions. They allow for quick constructions of lists. So to fully understand list comprehensions, we need to understand for loops. So don't worry if you don't completely understand this section, and feel free to skip it since we will return to this topic later. But just to give you all a little bit of a heads up, here are a few examples. So here we want to build a list comprehension by deconstructing a for loop within A. So that sounds like a lot, but in this one, new matrix not defined. Interesting. Okay, so before this, we were supposed to, I guess, define a matrix. And for those of you that don't know, a matrix is pretty much like an array, but with multiple rows and multiple columns. So in this case, we would call row 0, the first row, or we would set our first column equal to the first column of the matrix. And in order to do that, we would use our little list comprehension thing. But again, I don't really want to make a whole matrix, so just trust me on that. Yeah, so again, we'll use a list comprehension here to grab the first element of every row in a matrix object. We should cover this in much more detail later, since we will be working with matrices later on. All right, so there's another now try this. Again, because I kind of want to get through all this content, please try it on your own. It'll probably help you with the project, or not the project, the lab that you have to do. So for example, for this one, you have to build the list 0, 0, 0 using any of the shown ways above. All right, so here we will go over tuples. Tuples are very, very similar to lists. However, they are immutable, meaning that they cannot be changed. You would use tuples to present things that shouldn't be changed, like days of the weeks or dates on a calendar. So you'll have an intuition of how to use tuples based on what you've already learned about lists. We can treat them very, very similarly, with the major distinction being that tuples are immutable. So you construct tuples using parentheses instead of brackets like you would for arrays. or for lists. So for example, here we will create a tuple T that's equal to 1, 2, 3. Here we will check the length, again, like we could do for our both lists and strings. So we can also add a mix object types. So for example, here we have a string and an integer. And then when we print it out, we get 1, 2, but again, a string and an integer. We can use indexing just like we did in lists. So we can call the 0th index or first object, and we get 1. And then we can also do slicing just like we did for a list. So here we will call -1, which should give us our last index of the tuple. And in that case, yeah, it is 2. All right, so as we went over earlier, so there are built-in methods for certain data types. String has built-in methods, but tuples do as well, but not as many as lists. So let's take a look at some of them. So here we have .index. So when we call .index of 1, so you'd use this to enter a value and return the index. So for example, in our above in tuple, yeah, up here, we want to find the index of 1, or I mean like the string 1, and it will return 0 because 1 is the 0th index of the tuple. Here we can use .count to count the number of times a value appears. So for example, we can do t.count and call 1. So we want to see how many times the string 1 appears in our tuple. In this case, it only appears once, and it'll print that out for us. So again, can't be stressed enough that tuples are immutable. So just to drive that point home, here we will try and change it. We cannot. And it says tuple object does not support item assignment. So because of this immutabilities, tuples can't grow. Once a tuple is made, we cannot add to it. So here we will try to append like we did for the lists, but we will not be able to. Again, tuple object has no attribute append. So you may be wondering, why bother using tuples when they have fewer available methods? To be honest, tuples are used as often as lists in programming, but are used when immutability is necessary. So if you're in your program and you're passing around an object and need to make sure it does not get changed, this is when a tuple becomes your solution. So it provides a convenient source of data integrity. So now you should be able to use and create tuples in your programming, as well as have an understanding of their immutability. So here, there's another now try this. Again, please feel free to try it, but we're gonna keep going. So, yes.
What's the difference between an array and a list?
Yeah, so I've been using those interchangeably. They're pretty much the same thing. They're pretty much the same thing. I think in, I believe it's Java, like there's a difference between like arrays and array lists, but it's just, I've been saying array because I code in a different language, but it's pretty much the same thing. That's awesome. Alrighty, so now we will go into dictionaries. Dictionaries are a bit tricky. So we've been learning about sequences in Python, but now we're going to switch gears and learn about mappings. So if you're familiar with other languages, you can think dictionaries of hash tables. So what are mappings? Mappings are a collection of objects that are stored by a key, unlike a sequence that stores objects by their relative position. This is an important distinction since mapping won't retain order, as in no order to keys. So that sounds like a lot, but so a Python dictionary consists of a key and then an associated value. The value can be almost any Python object. So again, it sounds like a lot, but let's just jump into some examples so we can see how they actually work. So here we will make a dictionary. Dictionaries are made with the curly brackets and use a colon to signify a key and a value. So here, again, we will create a dictionary called myDict and set it equal to the curly brackets and then our key value pairs inside. So here we have key 1, and set it equal to value 1, and we'll have a comma separating them, and then key 2 colon value 2. So here is an example of calling a value by their key. So when we call myDict and then brackets and then key 2, we should get the value for it. So it's important to know that dictionaries are very flexible in the data types they can hold. So for example, we have myDict is equal to a big dictionary in which data types can be integers, they can be arrays, and they can also be pretty much arrays of any type. So yeah, they are very, very flexible. So let's run that. And then, so for example here, let's call an item from the dictionary. So we want to call key 3. And when we call key 3, we should get this array. So yes, we get the array of item 0, item 1, and item 2. We can also call an index on that value. So for example, if we wanted the value for key 3, and then knowing that it's an array, we want the first value of that array, we can call that and get item 0. And then we can also call methods on that value. So once we get item 0, we wanted it to be uppercase, then we can do myDict key 3, the first elements of key 3's value array, and then call .upper on it, and we get capitalized item 0. So we can affect the values of a key as well. So for example, here we will call key 1. So again, looking up here, key 1, its value is 1, 2, 3. So we can subtract 1, 2, 3. We can subtract 1, 2, 3 from the value. So if we set the value equal to the value minus 1, 2, 3, that should work, yes. And then when we print it out again, we should get 0. So yeah, hopefully that makes sense to everyone. Again, if it does not, please put something in the chat or feel free to unmute. So a quick note, Python has a built-in method of doing self-subtraction or addition or multiplication or division. So we could have used plus equal to or minus equal to for the statement above. So and instead of having to type out myDict key twice, we could have just done myDict key minus equal to 1, 2, 3, and that should have the same effect, right? Awesome. Yeah. So again, because we set it equal to 0. When we did that again, we got a negative number. Awesome. So we can also create keys by assignment. So for instance, if we started off with an empty dictionary, we can continually add to it. So here we create an empty dictionary D, and then we can create a new key through assignment. So we would do D, the name of our key, which is animal, and then the value of that key. So in this case, we want it to be dog. And then again, as we showed earlier, you can do this with any object of any type. So here we have, we set D answer equal to the integer 42. And so when we show this, we should have both of them. Yes, so we have animal, dog, and then answer 42, which is what we did up here. We just added them up to the dictionary. Alrighty, so you can also nest with dictionaries. Yeah, so hopefully you're starting to see how powerful Python is with its flexibility of nesting objects and calling methods on them. Let's see a dictionary nested inside a dictionary. So here, I know it looks like a lot, I know, but here is a dictionary nested inside a dictionary, nested inside a dictionary. So here we have 3 dictionaries, nested dictionaries. So here we have key 1, and that's equal to this whole dictionary right here. And then inside of that dictionary, we have nest key, which is set to this dictionary right here. And then finally, we have a subnest key, which is actually equal to a value and not a dictionary. So when we run that, okay. So I know, again, it seems complicated, but this is how we would grab a value. So in order to grab a value of a nested dictionary, we just have to keep calling the keys of the values that we want. So for first, we would call key 1 because it's like the outermost key. Then we would call the next key, which is nest key. Then we would call the subnest key. And then that should give us our actual value. Awesome. So yeah, I know it's a lot, but there's a now try this later that will give you some practice with it. And I highly recommend you try that because it's like a little puzzle. There are a few methods we can call in a dictionary. So really quickly, let's introduce a few of them. So here we will create a dictionary, normal dictionary, not nested. Here is a method to return a list of all the keys. So if we call D and then dot keys, it should return a list of all the keys. So yes, here we have key 1, key 2, and key 3 that do not include the values of the keys. We can call D dot values to grab the values of the dictionary. So here we have 1, 2, and 3. Again, the values not including the keys. And then here we can call D dot items that will return tuples of all the items. Again, we went over tuples earlier. They're immutable. That's pretty much all you need to know about them. But yeah, so here we get key 1, all the key value pairs in our dictionary. So as I said, here we have a now try this. So it'll pretty much have you call or find hello in all of these dictionaries, and these get progressively harder. So for example, our very last dictionary, it says, this will be hard and annoying. So please try that one at the very least. It's all very doable, but again, it's good practice. So if you have any questions about this when you try it later, please feel free to contact Danae or I or Kyle. Alrighty, so here we have some comparison operators. So comparison operators will allow us to compare variables and output a Boolean value. As we went over, Boolean values are just true and false. So these operators are the exact same as you've seen in math, so there's nothing new here. And then here we have like a table of some of the operators. So we have equal, which is like to see if 2 things are equal. If they're equal, then it will output true. Not equals to, again, if you call that on 2, it will, if it's not equal to, then it will call true. We have our greater than, you know, if 2 is greater than 1, it'll output true. If 1 greater than 2, you know, false. And then we have the same thing for less than, and then here we have greater or equal to and less than equal to. So let's work through a few examples just to see what I'm talking about. So here we have our equal, which is again the double equal sign. If we say 4 is equal, if we ask if 4 is equal to 2, 4 is equal to 4, we print out true. If we do the same thing with 1 and 0, we should print out false because they're not equal. Oh, and then also note that the double equal is a comparison operator, while the single equal is an assignment operator. Yeah, so pretty much if I tried to set 1, if I wanted to see if 1 and 0 are equal, but I only had 1 equal sign, it would give an error. So we have the same thing for not equal, except there's a exclamation mark. So 4 is not equal to 5 is true, but 1 is not equal to 1 is false. Here we have greater than, so 8 greater than 3, true, 1 greater than 9, false. And pretty much we have the same thing for less than, greater or equal to, and then less than or equal to. So hopefully this was more of a review than anything new. Next, we'll move on to one of the most important aspects of building programs, functions, and how to use them. Okay, so I will see how much I can get through. I will probably speed through this for another, hopefully 10 more minutes if you all are willing, 10 or 15 more minutes if you all are willing to listen. If you need to go somewhere, please feel free to leave. Again, this recording will be up and a link in the GitHub, I believe. And then also, again, this whole thing will be available to you all at all times. So, alrighty, so functions, introduction to functions. Here we will explain what a function is in Python and how to create one. Functions will be one of our main building blocks when we construct larger and larger amounts of code to solve problems. So what is a function? Normally, a function is a useful device that groups together a set of statements so they can be run more than once. They can also let us specify parameters that serve as inputs to the functions. So on a more fundamental level, functions allow us not to have to repeatedly write the same code over and over again. So if you remember back to the lesson on strings and lists, remember that we use the function length to get the length of the string. Since checking the length of a sequence is a common task that you would want to write a function that can repeatedly do this command. So again, functions will just be one of the basic levels of reusing code in Python. So you can start, this will allow us to start thinking about program design. So here, let's see how to build out a function syntax in Python. So it has the following form. So here we have, it will begin with def, so def, then followed by space, and then followed by the name of the function. So again, we have a space and then the name of the function. Try to keep these names relevant. For example, lang is a good name for a length function. But again, also be careful with names, as you wouldn't want to call a function the same name as a built-in function, such as length. So next comes a pair of parentheses with a number of arguments separated by a comma. So these arguments are the inputs for your function. You'll be able to use these inputs in your function and reference them. And then after this, you have a colon. So again, we have, for example, we can have as many arguments as we want or no arguments. It really depends on what we need. And then we will have a colon. Then everything after that is the actual function body. So yeah, so now here's an important step. You must indent to begin code inside of your function correctly. Python makes use of white space to organize code. Lots of other programming languages do not do this, so please keep that in mind. So again, you need to have white space here or tab here just to signify that it is the function body after the colon. So next you see a doc string, which you'll write a basic description of the function. They're not necessary, but it's good practice to do them, especially if someone's going to be reviewing your code and just, you know, it'll let people know what that function does. After this, you can begin writing your code that you'd wish to execute. Yeah, after this is just whatever the actual function is going to do. So here we have a simple print hello function. So here we have def, a space, and then the name of the function, which is say hello. And then inside of this, we have some white space here, and then our actual, like the command that we want to run. So this would be print hello. So when we call say hello, and then the parentheses, oh, sorry, I didn't run this one. Now this should work. We get hello, because it just prints hello to the console. So here is a function that greets people with their name. Again, these are just simple functions to let you all know like how to create functions. So here we have a function called greeting. It will take in one parameter called name. And then once we get that, we will actually print out hello name. So this is just like, this is how you print out a variable. You would have inside of like a string. So you would have the percent and then S, and then you would call the variable inside of parentheses, and then like your, what is it called? Percent sign. Here we will call this function greeting, and then instead of, we'll actually like input a name in. So we will have,
What does that percent sign do?
right. So it allows us to like pretty much take our variable name and put it inside that string. Like if we tried doing like instead of having this, hold on. Like if we just tried to do that, it wouldn't work. It would just print out hello name. Even though we have name as a variable, when we have it inside of a string, it can't like detect it. So instead we have to do something along the lines of this, where, you know, Python knows that, okay, we're gonna be referencing a variable when we call the percent and S, and then it'll look for, okay, what variable are we trying to reference? And then it will have, it'll look to the right of that, and then that's where it'll call name. I'm losing my voice. I never thought that would happen. Wow. Yeah, does that kind of make sense?
Yeah.
Okay, there's also another way to do it, but we can get to that later if we have time. All right, so when we call greeting Bob, it should print out hello Bob. Again, it just took our variable name and put it in place of that percent S, so we get hello Bob. All right, so we can use return, the return statement. The return allows a function to return a result that can be stored as a variable or used in whatever manner a user wants. So for example, here we have an addition function in which it will add two numbers, num1 and num2, and return it. So again, it'll add these two and then it will return it. So when we call, actually, let me do that. So when we call add 4 and 5, it will return 9. So we can also save as a variable due to return. So when we call add num and add num 4 and 5, it will return the value 9. We can set that equal to results. So when we do that, hold on. Nothing will actually print out, but when we print result, we should get our answer. Yeah, so we get 9. So what happens if we input two strings? So again, this function is taking these two strings, these two parameters and adding them. So when we do that, it'll actually print out 1, 2. So yeah, because they're strings, it'll have the concatenation operator. So luckily Python allows us to do that. So we can also use break, continue, and pass statements in our code. So yeah, I don't think we had a while lecture, but hopefully this will make sense. So did I miss something? Wow, okay. Well, here is a full example of a function to check to see if a number is prime. And this happens to actually be like a common interview exercise. So we know a number of prime if that number is only evenly divisible by 1 in itself. So let's write our first version of the function to check all the numbers from 1 to n and perform modulo checks. All right, so I know this sounds like a lot, but let's just go through this line by line. So here we have a function is prime, it'll take in a number. And then here we have a for loop. And I don't know if we've actually gone over this, but pretty much for loops will just go from a certain start value to a certain stop value. So in this case, it'll start at n it will go from range 2 to our number. So our number being whatever number we will actually want to put in. So in our first example, let's just go with 16. So it'll go from 2 to 16. So for each step, we will see if the number modulo n is equal to 0. If it is equal to 0, that pretty much means that it is divisible by a number other than itself, meaning it is not prime. And so in this case, we will break. Otherwise, if it gets through the whole range of numbers, then you will know that it actually is prime. If it gets through the whole range of numbers and it is in this like print, or this condition is not true, then we will know that it is prime. And we're safe to print out num is prime. Hopefully that made sense. I know there's another example of this below, but so example 16, so 16 is not prime. Wait, is 16 prime? Oh yeah, 16 is not prime. Yeah, there we go, sorry. And then when we call the same thing on 17, 17 is prime. Again, because 16 is divisible by what, 4, and 17 is only divisible by like 1 in itself. So
we're gonna do a math class. We're gonna do a math big camp just for you.
My basic math is so bad. It is literally so bad. I was trying to explain something to Danae the other day, and I kept saying the wrong way of subtraction. It was just
saying subtracting 1 instead of subtract from 1 because, you know, commutative property, but that's okay. You can keep going.
I know, it's so bad. Yeah. All right, but so note how the else lines is under the for and not under, like, directly under the if. So this is pretty much because we want the for loop to exhaust all possibilities in the range before printing out our number as prime. And then also notice this break here. So as soon as we determine that a number is not prime, we want to break out of the loop. This is because we don't want to keep going if we already know that the number is not prime. That would just kind of like be a waste. So here, we can actually improve this function by checking the square root of the target number, by only checking to the square root of the target number, and by disregarding all even numbers after checking 2. We'll also switch to returning a Boolean value to get an example of return statements. So in this case, it's a little bit more complicated than the value above, but it is also more efficient. So here, we will have an initial if statement that will check to see if the number we have is like divisible by 2, and if the number is greater than 2. If it is, then we know it is false and that it is not prime. So then from there, we only have to do a range from 3 to the square root of the number. Again, it's just how math works, I guess. So we love that. But in this case, we know that if the number mod whatever value we have is equal to 0, we can return false. Again, if it's divisible by any of the numbers from range 3 to the square root of itself, it's false. Otherwise, we return true. So here we have an example of that. We have is prime. Oh, I didn't run this. Huh. So we'll run that and then we'll call it on this, and we get false because 27, again, divisible by numbers other than 1 in itself. So for this, we didn't have any break statements. And the reason for this is because as soon as the function returns something, it shuts down. Earlier, we had to use a break statement because the for loop would have just kept going until the end. But in this case, again, because return just kind of like stops all execution, we don't need to have a break statement. So here we have a now try this again. Please, please, please try this. Your task is to write a function that capitalizes the first and fourth letters of a name. and it gives you the hint that you might want to use the dot upper method. Alrighty, so I'll keep going. So modules, pretty much Python has, so modules in Python are simply Python files with a .py extension, which implements a set of functions. Modules are imported from other modules using the import command. So to import a module, we use the import command. You can check out a full list if you look it up. There should be a link, but there's not, but we can look that up. Yeah, so the first time a module is loaded into a running Python script, it is initialized by executing the code in the module once. If another module in your code imports the same module again, it will not be loaded twice. So pretty much modules provide like functions that you can use. So for a common one is import math. And once we do this, let's say we wanted to use it to round, to like do the ceiling rounding, which I don't know if any of you know what that is, but it's like if you had 3.2, it would round up to 4. And instead of us having to write a function for it, we just have to import math and call that. Yeah, so run this and it rounds up to 4. All right, so now we'll get into NumPy, which again, this is what we'll really be using for the next few weeks. And NumPy is just a library for Python that allows you to create matrices and multi-dimensional arrays, as well as perform sophisticated mathematical operations on them. So previously, we've dealt with like single dimensional arrays, which was a very difficult base in Python. Additionally, there weren't a lot of built-in functionality to perform many standard mathematical operations that data scientists typically do with data, such as transposing, dot products, cumulative sums, etc. So NumPy pretty much makes it very useful when you're doing like statistical analyses and analyzing data sets to produce insights. So really quickly, we're going to go through some great built-in things of Python, of NumPy. Then we should be done. So just hold on for like another 10 or 15 minutes. I'm so sorry. All right, so here, this is how you create an array in NumPy. An array object in NumPy is called ND-array, which is short for n-dimensional array. So for example here, again, as we talked about earlier, we just import NumPy as NP. So whenever we want to call a function in NumPy, we just call NP and then dot whatever function we want to call. So here we'll call NumPy or NP.array, the array we want, which is just like you do that by putting the array that you want, and we'll set that equal to array. And then we'll print it, and we can also print the type of array by calling type. So here we print the array, we get our numbers 1 through 10, and then when we print the type of the array, it'll give us numpy.ndArray, which again, as we said earlier, arrays in NumPy are ND arrays. So just like earlier, we can also call we can also index the array. So again, we'll create another NumPy array, and then when we can index it pretty much like we did earlier arrays. So I mean earlier lists in Python. So we can call array and then have call the 4th index and then add that to the array of or the 8th index of the array. So when we call the 4th index, we get 0, 1, 2, 3, 4, and then the 8th index is 5, 6, 7, 8, and then we get 14. Awesome. So slicing. So slicing in NumPy behaves much like in base Python. So a quick recap from above. You know, we have the slicing with the colon, so we have our start and end, and then we can also define a step. I don't know if you all remember, but earlier when we were doing the string stuff, we were able to like skip certain characters if we wanted. You're able to do that with NumPy arrays. So here we just print the array from in reverse. Again, that's the double colon and the negative one. Comes in handy, so please remember it. And then also here, we will call everything up into 8, from the beginning to index 8. So yeah, that's what we have there. Again, so you'll notice that we only got to index 7. That's because the end is always non-inclusive. We slice up to, but not including the end value. So, and here we have a now try this, in which you'll have to create an array of at least 10 and populate it with random numbers. Then use slicing to split it into 2 and create 2 new arrays. Then find the sum of the third digits in the array, in each array. So again, this is all very, very good practice. Please go over this on your own time. Awesome. So we have some data types. Yeah, so they're all differentiated by a single character, and here are the most common. We have I, which is integer, which again, whole numbers. We have B, Boolean, true, false. F, floating point numbers or decimal numbers. And then we have capital S for string. And there are many more. So here we can actually call the dot D type on a NumPy array. And we're able to see like what type of array it is. So you can actually convert between types. So if we have an array of all floating point, we'll print that array out and then call to and see what type it is. If, for example, we didn't want floating point and we wanted integers, instead we can call that array dot as type, and then I, which again is the thing for integers, and it will be able to like convert that whole floating point array into integers. So again, here's our floating point original array, and then after we have our integer array. So here, again, another now try this. There's an error. So you would have to fix something in order to make it work. And again, this has to do with like type conversion. So please look at that. All right, so in NumPy, you can either create a copy of the data or the data itself. It's very important that you know the difference. So again, this is copy versus view. So you can either create a copy of it, in which when you do, and then you try to, and you change the value of your copy, you'll be able to do that. So for example, here, I changed the first value equal to 8 from 6. And then when you view it, you're actually changing the actual value of the original array too. It's not just your own copy. So for example, here when I changed it to 8, both of them changed instead of just 1. Again, another now try this. The student wants to create a copy of an array and modify the first element. This is the code that they wrote. Is it correct? So again, really good exercise. Please try it on your own time. So all NumPy arrays have an attribute called shape. And this is really helpful for 2D or n-dimensional arrays. But for simple lists, it is just the number of elements that the list has. So for example, here we'll print the shape of the array. It's only 1 row, but it has like 4 columns. So we'll print out 4 and then nothing. So here's another now try this. It says without using Python, so don't run this. What is the shape of the array? So answer in the same format as the one above. All right, so there's just a bit more. Yeah, there's just a bit more. So you can iterate through arrays, and iterating pretty much is just traversing or traveling through an object. In the case of arrays, we can iterate through them by using like simple for loops. So here we have a NumPy array with 1, 5, and 7 in it. in order to iterate through it, you call for x in array. So for each of these numbers in the array, just print them. So when we call that, it should print out 1, 5, and 7. Again, if you need some help with the syntax, please let Danae or I know, or feel free to look up for loops on Google. All right, so you can also join arrays, kind of like you would join strings, but a little bit different. So here we have one array with 7, 1, and 0, and then here we have another array with 2, 8, and 1. When we call numpy.concatenate and then the two arrays that we have and set that equal to a new array, we'll actually have all of the values that I stated above. Again, a lot of these built-in things you don't have to remember, but if you ever need it, you can like look it up, like look up built-in functions in NumPy, and you can do that, or for NumPy arrays. All right, so the opposite of splitting is joining arrays. It takes one array and creates multiples from it. So here we have one really, really long array, and we want to split the array into 4 pieces. When we do that, we get 4 mini arrays, each with some of the values of the array above. All right, so you can also search an array to find a certain element, and this is a very important and basic operation. So we can do this using the where method. I honestly think this is really cool. So if we had an array and we wanted to find where in the array is equal to 4, it will return the index of the array elements that matches this condition. So for example, it'll print out 6, and where in this array is 4, we go 0, 1, 2, 3, 4, 5, 6. Yeah, so again, it'll just print out the index. And then you can also use it to do some more advanced stuff. In this case, here we have an array and we want to find all of the odd numbers in the array. So we will call np.where, and then our array modulo 2 is equal to 1. So where all of the ones are odd. Yeah. Yeah, so again, it'll call 8. And because all of these are even, it'll call the very last one, which is 99. All right, so you can sort arrays. Again, this is a very important and commonly used function. You can use np.sort for this task. So for example, if I had the array 4103 and I called np.sort and then our array, it'll print out 0, 1, 3, 4. So again, it does it in order. And we can also do this with strings as well. So if we had Zephyr, Gate, and Match, it'll pretty much take the very first character and see, like, does G come before Z? Does M come before Z? Stuff like that. So when we sort it, we'll get Gate, Match, and Zephyr. All right, so again, coming to the end. Woo. So here we'll go a little bit over filtering arrays. So again, this is like a very, very commonly used thing. So sometimes you'd want to create a new array from an existing array where you select elements out based of a certain condition. So let's say you have an array with integers from 1 to 10. You would create an array with, and you would like to create an array with only the odd numbers from that list. So you can do this very efficiently with using filtering. So when you filter something, you can you only take out what you want, and the same principle applies to objects in NumPy. So NumPy uses what is called a Boolean index list to filter. This is an array of true and false values that correspond directly to the target array and what values you would like to filter. So for example, using the example above, the target array would look like this. So we have our numbers 1 through 10. We would like to filter out the odd values, and you would use this particular Boolean index list. So we would have true, false, where the trues are the the odd values, and the falses are the true, wait, what did I say? And the falses are the even values, right? So applying this Boolean index list to the original list will give us 1, 3, 5, 7, and 9. Again, so it'll give us all the odd numbers, which is what we want. So this is actually an example of what we just did or just explained. So here we have our NumPy array with 51, 52, 53, and 54. And we only want certain values. So let's say the 53 and 54. We can make a Boolean index list and put false, false, true, true. And then we can apply that list to our array. And again, it's just syntax that you'd have to familiarize yourself with. But you would just do array and then X to get your new array. So when we print that, we actually get 53 and 54. Again, the two values that had true. All right, so we don't actually need to hard code the true and false values. Again, that can be really inefficient, especially if the array gets way too large. So we can filter, as previously stated, we can filter based on conditions. So we will start out with the array that we had before, 51, 52, 53, and 54. We will create an empty list. Again, this is where our true and false values would actually go into. So, so we would go through each element in our original array, the ones with the 51, 52, 53, and 54. And so for each of those elements, we will see, or we only want, if the element is higher than 52, set the value to true, otherwise false. Alrighty, so in this case, if element is greater than 50 true, we would append true into our empty list. And if otherwise, we would append false. And then again, like we did earlier, we would apply that our filter array to array and print that out to see if we get the right answer. And we do. So again, we printed out the filter array, which had false, false, true, true. And then we printed out our new array, which has the result that we want, 53 and 54. So filtering is a very, very common task in working with data, such as NumPy. Working with data and such. NumPy has an even more efficient way to perform it. It is possible to create a Boolean index list directly from the target array, and then apply it to obtain the filtered array. So for example, here we have a NumPy array from 10 to 100, skipping tens. So we want our filter to be everything greater than 50. Instead of having that for loop like we had earlier, if we just call array greater than 50, it'll actually create a array for us, which is actually kind of cool. And so when we call array on our filter that we created and print that out, we should actually get everything greater than 50. And this is what the Boolean list thingy array looks like. Awesome. So again, there's a final, now try this. Create an array with the first 10 numbers of the Fibonacci sequence. If you don't know what that is, please look it up. It's so split this array into two. On each half, search for any multiples of 4. Next, filter both arrays for multiples of 5, and then finally take those two filter arrays, join them, and sort them. So again, really, really good exercise. Please try it on your own. And with that, yeah, I think we're done. Wow. Okay. So thank you all for coming and staying. If you have any questions, please reach out to Danae, I, or Kyle. We'll all be glad to help. And yeah, so there's an office hours thing in the Slack, which Kyle will hold. So if you need help, please join those office hours. And yeah, thank you so much, everyone. I hope to see you all next week.
Yeah, and once this recording goes through, I will send it in the Slack.
Awesome.
Thank you.
Bye, everyone. Thank you.